Welcome back, everybody. This video is going to cover the Pythagorean theorem. So before we start doing some Pythagorean theorem problems, I want you to know that this can only be done when we have a right triangle. So if you do not have a right triangle, don't you dare try to do the Pythagorean theorem. It must be for a right triangle. Also, you need to know your parts in a right triangle. The two sides that form the 90-degree angle are known as legs, and the side that's opposite is known as your hypotenuse. So when you're doing the Pythagorean theorem, it's a squared plus b squared is equal to c squared, but really what it's saying is you add your two legs squared and set it equal to the hypotenuse squared. It does not matter which order your a and b are. The most important part is you must have your hypotenuse as the leg, or the side that's by itself. So let's go try a couple examples. So we have x that we're looking for, and our legs have to be a and b, and you can switch those. It honestly doesn't matter. The most important thing is that your hypotenuse is c. So then we just go set it up. We have 3 squared plus 4 squared equals x squared. And from there, you just move on. So 3 squared is 9, plus 4 squared is 16. That's equal to x squared. Add those two together. 9 plus 16 is 25, is equal to x squared. And then, to solve for x, instead of x squared, you just have to square root both sides. And we end up with x is equal to 5. Okay, so the length of the hypotenuse is 5. Now, whenever you do the Pythagorean theorem and you get 3 nice numbers, it's known as a Pythagorean triple. So this would be called a 3, 4, 5 Pythagorean triple. Which can save you time if you memorize some of the Pythagorean triples, but it's obviously not mandatory. So this next example here, it's very similar, but this time your hypotenuse is a number, which is fine. We can still do this. So we're just going to set up x squared plus 5 squared is equal to 13 squared. And then you square your terms, so you still have x squared plus 25 is equal to 169. But now you just have to make sure you subtract the 25 over to the other side, and you have x squared is equal to 144. So whenever the hypotenuse is by itself, you don't have to do that subtraction step, but you have to make sure that your hypotenuse is the one that's by itself, so you just have to subtract 25, no big deal. And then square root both sides, and you get x is equal to 12. And again, you notice that we have another nice pretty number. This is considered your 5, 12, 13 Pythagorean triple. And there's a whole bunch of Pythagorean triples. If you know how to use them, it saves you time. I will show you in class how to use them if you want to memorize some of them. Again, it's not necessary because these examples are going to show you non-Pythagorean triples. So this example right here, we're just going to do our Pythagorean theorem of 5 squared plus 10 squared is equal to x squared. We're going to have 25 plus 100 is equal to x squared, which means 125 is equal to x squared. Now, the square root of 125 is not a nice, pretty number. So you're going to have to use the factor tree to simplify it. So you're going to have 25 and 5. Break that down. You get 5 and 5. So you circle a pair of 5s, box your leftover. It doesn't really matter how you learned how to simplify a radical, as long as you know how to do it right here. So that would simplify to 5 square root of 5. Okay, so the last one is also not going to be a nice pretty Pythagorean triple, but I would like you to pause the video and see if you can handle that guy on your own. And when you're ready, click play, and we'll be done with this video. So to set this up, you should have x squared plus 6 squared is equal to 12 squared, or the other way around is just fine. And that's going to give you x squared plus 36 is equal to 144. And then you need to subtract 36 from both sides, and you get x squared is equal to 108. And then after you subtract or take the square root of both sides, you should end up with x is equal to 6 root 3. Okay? So that is the Pythagorean theorem for you. This is Longo and I'm out. See you, bye.